Okie dokie. Right, so the first one, let's have a look. Okay, so the first one's okay, wasn't it?
Yeah.
He kicks a ball, what's the impulse? So, number one, the impulse is the change in momentum, which is mv minus mu, but that's 0. Whoops, so what was it? It was 0.4 and 0.5. So that is 0.2 kilogram meters per second. Right, so that's okay. The cat that falls off the roof. And the roof is 5 meters high, and the cat is at 5.5. Right, so cat. Oh yes, yes indeed. And it is 5 meters high, and it's a 5.5 kilogram cat. And when the cat lands, it takes. So the cat lands with its legs up, and then it bends the legs, and this time is 0.25 seconds. So is that okay so far? The picture, the idea? Yep. So what we need to know first is how fast the cat is going when it hits the ground. So UVATS 0, don't know, minus 9.81, don't know, 5. Thank you, Amanda. Minus 5. So did you get the V? Yeah, what did you get? You can just tell me.
1 No, just 1.01.
Yeah.
No minus.
No, it is minus because it's going down.
But the acceleration and the distance is minus.
Yeah.
Minus, so
Yeah.
becomes plus.
Yeah, but you have a square root in it, yeah?
Yeah.
Yeah, so when
your number is plus, when you square root, it's also plus.
No, square root.
Yeah, I know. I forget.
That's okay. That's okay. So now we look at this part of the journey from here to here. So the U is minus 1.01, the V is 0, the A we don't know, the T we do know, and the S we don't know. And I really want to know the A. Did anybody get it? No? What did you get, Amanda?
Sorry, I said it wrong.
What is it?
It's maybe.
I get my calculator.
No, 9.9 meter per second. Because I get the wrong time.
That's okay, I will check. No problem. Yes, that's correct, Grace. The cat bends his knees. The V is 9.9, yes? 9.9. It's fat cat too. Spider cat, yes. Where's my pen gone? Pen. Right, 9.90. 9.90. So if we calculate the A here by using V squared minus U squared, V squared equals U squared plus 2AS. Oh no, I can't use that because I don't know the F, so I should use V equals U plus AT. So I get a very big A, 39.6. To get this one, V equals U plus AT. Yeah? I forgot what I'm looking for. How much force? So what's the force? Okay. So you can use F equals ma.
But I understand why the thin distance
Yeah,
calculate the
yeah.
impulse.
Yeah, well, you see, there's two ways to do it. So let's just see that we get the same answer if we use this or if we use this, the impulse. So, what's the M? 5.5, and the A? 39.6. Sorry, you know what? I didn't need to calculate this. So I only need to calculate this if I want to use this formula. And then I get 217.8 newtons. But if I didn't calculate that, I can just calculate the impulse, which is mv, which is 0, minus mu, which is 5.5 times minus 9.9, sorry, I have too many minuses here, over 0.25. So I should get the same answer. I sure hope I do. And I do. 217.8 newtons. So again, we can see that these formulas are the same thing. Did anybody get that answer?
No.
What did you get, Grace?
1375.
What was the mistake?
Everything.
Everything. Okay.
From
From
the beginning.
the beginning. Okay. You did a dog, not a cat, yeah?
Yeah,
Yes.
I didn't do the
Okay.
But
everything's gone.
Okay.
But how do you calculate the impulsive force without? But you have to do the first one first, right?
The impulse was from when the cat was at rest to the cat, from the cat being just before it hits the ground.
Until it bends its knees.
Until it fully, comes to rest. Yeah.
So you have to calculate the velocity until it reaches the ground, right?
Yes. Yes. Yeah.
Okay.
Yeah. So then that way you have the momentum immediately before it bends the knees, and then immediately after bending the knees it's 0. Okay? Is it? No. All right. You are walking. So I said you. So I'll do it for me. I don't know my height. I'll estimate it. Hang on.
1.8.
I don't know my height. I'll check it.
2.0.
2.0, no. Definitely not 2.0. I know that. Right. So here I am. Got my coffee here. Looking good. No, actually, but I'm walking into the wind, so the coffee is blowing backwards, and the wind is blowing this way. Right, so what we're doing is we're thinking about me like this. This is me now. I'd say I'm 182. 1.82. How wide? That's a good question. Probably more than 30. 35? 36? Maybe. Now, the one difference here is that I'm walking. So let me just go to the side here. If you look here for a moment, please. This is at rest, and this one is moving towards it at 1 meter per second. So when this hits it, it feels like 1 meter per second. But what happens if this was moving at 1 meter per second and this was at rest? Well, it still feels like this hits you at 1 meter per second. Do you get the idea I'm trying to get here? That if this was not moving and I moved 1 meter per second, that's the same as if this is not moving and this one is 1 meter per second. So it can be like this, or it can be like this. So you don't care who's moving, you only care about how fast they are compared to each other. So, for example, if this is moving at 1 and this is moving at 2, it's like this is not moving and this is moving at 3. Yeah. So, like if two cars crash, 60 kilometers an hour, 60 kilometers an hour, it's like 120 because they're both moving towards each other. Yeah. So with the wind example, because I'm walking at 1 and the wind is 20, it's like the wind is going at 21. So this is 21 meters. Now, we'll look at this over a per second basis. So the time is 1. Density is mass over volume. So mass is density by volume. So mass is 1.225 times the volume. Times the volume. So the mass is 1.225 times 1.82 times 0.36 times 21. Actually, I think I can know what my width is.
Yeah, but how do you know the volume?
The volume of what? The
Of
box of air.
yeah.
Well, I know in 1 second I only care about the air which is 21 meters in front of me.
Okay. Okay, then it's just your time and your...
Yeah, now actually I can make my width more accurate. Let me see, I'm about...
So are all our answers going to be different?
Yes.
Okay.
Hey, I'm not 36, I'm only 31.
Happy?
Oh, very happy. So I'm only 31. That's better. Okay, so the mass of the wind here is 1.225 times 1.82 times 0.31 times, now sorry, that's that's a 21. So that's 14.5 kilograms. Okay, whoops, sorry. So now we can get the force is the change in momentum over time. Oh, sorry. It's the mass of the gas times the velocity of the gas. This is like for the rocket. So it's 14.51 times 21, which equals 304.7 newtons. Yeah. Did anybody get this?
I didn't know we have to use our own
That's okay.
thing.
Did you all use 20 instead of 21, was it?
No, I didn't know we're supposed to use our own.
That doesn't matter. What did you use?
I didn't use anything because I thought there was not enough information, so I
Ah.
didn't do it.
But look, I've highlighted in red. You. It doesn't matter. Sophie, did you get it?
Why did we use x equals mv?
Because I'm thinking this question is like the gas that is coming out of the rocket. The only difference here is you are like the rocket and the gas, instead of going down, is going up. So you have to give a force to cancel it. But it's the same idea, it's a gas hitting something. Now if you wanted to, you could also think about it like this as well. This would be 1, and this would be mv minus mu. But the mu is like 0, because what happens here is the air is at rest, and then the wind comes and blows on you a force. So here you would get the same thing. Same answer. Is that okay, Sophie?
Yeah.
Yeah? Grace, did you get this? You said you used 20 instead of 21.
And I get 35.2.
For your width?
Correct.
For F? 35?
Oh, no. It's 11. I thought it's 1.
What's 11?
They are me.
Oh, here.
Ah, 235.2.
Why is your number small? Maybe someone can answer. Why is Grace's number smaller than my number?
Different, why different top?
Different area.
Yeah.
So if the area gets bigger,
More force.
more force from the wind. Yep. Yes?
The area gets bigger, force will become bigger.
Yes. So the person must push harder to walk through the wind.
Like today.
Like today, yes. Yes, like today. That's kind of a lot, isn't it? 300 newtons. Anyways, can we go to the next one? Yes. The very difficult one. A very small rocket is at rest on a launch pad. The engine is off when T is less than 0. The mass of the rocket is 100 kilograms. 90% is fuel. It ejects at a rate of 9 kilograms per second at a speed of 100 meters per second. Right, so, number 4. Now, this question is long and it's difficult, but parts A to F will be what you would get in the exam. Grace, are you listening? What did I just say?
In the exam.
The rest of the sentence. Part A to F is what you get in the exam. Parts G and H are a little bit too difficult for the exam, but we'll do them anyways, okay? Right, so the first question is, what is the weight? So here is the rocket, and it is 90 kilograms fuel, and then 10 kilograms. Does anyone know what you call the part which isn't the fuel? So, you think you... Oh yeah, yeah, that's okay. Give me something else.
The fuselage.
Now we're getting fancy. We can just call it the cargo.
Okay.
Or you can call it, if it's cargo will do. Right, so what's the formula for weight? Well, weight equals mg, which equals 100 g, which equals 98.1 newtons. That's okay? Yep. B. What is the reaction force when T is less than 0? Can I go down a bit? What's wrong, Grace?
150.
Yeah.
981.
Oh, thank you. Alright, B part? Yep. Okay, so here is the rocket, and here is the weight, and here is the reaction force, and this is before it takes off. Before. So what does the reaction force equal here?
0.
No?
Because it hasn't taken
No?
off.
981.
Thank you.
Oh, I mean.
0. I mean 981. Yes. Okay, you got that? Yep. Okay. See.
Why does it say T is smaller than 0?
Yeah, I'm just trying to make it clear that it's before it takes off, before the engine is on.
Okay.
C, what is the thrust? So, for this part, you turn the engine on. So the engine goes on, and now you have it still on the ground. So now you have a reaction force here, and you have a force from the engine, and then you still have the weight. But anyways, we just care about this part here. So we can use our formula mv, and if you look at the question, it is 9 kilograms per second at a speed of 100 meters per second. So that is 9 times 100, so that is 900 newtons. T is the force from the engine, the thrust, the up force.
Force from
The engine.
the engine.
You know, it's like engineering, what you're studying.
Yes.
No problem. Right. D. What is the reaction force? So here we have R plus T equals W. So we get R equals W minus T. So R equals 981 minus 900, which equals 81 newtons. Can I go down a little bit, like to here? Yes. So if we have a look at our picture, it's like this. The engine is given it 900 newtons. What's the weight? 981. Will the rocket move? Will it move?
Yes, it'll move down.
No. Well, yes, in this picture it would move down. So you would need a reaction force from the ground of how much? 81 newtons. That's the answer we got.
But it's moving up, right?
Well, not at the beginning it's not. You see, this is the thing, when the engine is first turned on, there's not enough thrust for it to move up.
So it's still equal.
It's still equal. Still equal.
Okay.
It's not moving yet. Okay, next part is, why doesn't it take off? Well, the answer for part E is because the thrust, which is 900 newtons, is less than the weight, which is 981 newtons. So the reason is because 900 is less than 981. That's why it doesn't take off.
Okay.
There's just not enough force from the engine. So then the next part, when will it take off? So I wonder if anybody has any ideas. How can I get the next part? When will it take off?
When there's more.
When the weight
Because it's something first.
Yeah, that's it. That's it, that's it. The force that's going up, the 900, doesn't change. It's always 900 because the gas is the same. But as Amanda said, the weight will change. Why will the weight change? Why will the weight change?
Because the gas.
Yeah, because the gas comes out, the rocket is getting lighter. So if you think about what happened is this gas is coming out the bottom. As this goes down, the rocket will get lighter. When will it take off? Well,
Light enough.
yeah, which is how much? When the weight is what?
And the weight is less than 900.
Yeah, so when the weight is 900. When the weight is 900, then the 900 going up is enough. And then when the weight is less than 900, then it'll take off. So we want to calculate how long that will be. So we want the weight to equal 900. So we want mg to equal 900. So we want the mass to equal 900 over 9.81. So we want the mass to be 91.7 kilograms. Now, the mass starts at 100 kilograms, but then every second, how much does it lose? Do you remember?
It loses 9 kg.
It loses 9 per second. Loses 9 kilograms per second. So, we want to lose 100 minus 91.74. We want to lose 8.26 kilograms. So how long do we need to wait? Less than a second.
Yeah.
Nearly 1 second. So we just need to wait 0.92 of a second. So basically after 1 second it should be moving. That's okay? Have you ever seen a video of a rocket taking off?
Yeah.
And you'll notice if you watch the video, the rocket at the beginning, when the engines turn on, it looks like it doesn't move. Question? No, I'll put it back. I just want to get a video here. Okay. Okay. Maybe this is not really the one I want. Yeah. Okay, let me go back. Please watch. What you doing? Now watch. Watch. Okay, so this is the rocket. Tiny, small rocket. Now, the gas is coming out. It hasn't moved yet. And see, there's still more gas coming out, and only now does it start to move. In other words, it doesn't start moving at the beginning when the gas comes out. Rocket, take off, slow motion. Yeah, we want to see a real rocket, I know, of course, not a toy rocket. Yeah. Something like this. Thank you for the music. Now, see here on the video.
Higher.
So the gas is coming out, and yet the rocket's not moving. Gas is still coming out, rocket's not moving. Is it gas? Yes? Yes. It's a bit dark. Okay, too much smoke. Where's the rocket? Yes. And now look, now you can see here, look, the gas is still coming out and the rocket has not moved. Still on the ground.
So does that mean they don't need to put like a lot of fuel, they just need enough?
Wait. Still hasn't moved yet.
Mm-hmm.
Gas still coming out because the rocket is too heavy yet. More gas needs to be burned. Still not moving.
Why are things falling?
Things are falling. Stuff is happening. Still not moving.
Why?
The rocket is too heavy.
Why is falling?
It's the part that holds the rocket. Are we moving? No. Yes, take off. Full thrust. Now it's moving. So now, what I wanted you to see was that the rocket doesn't start moving at the beginning. There's a little bit of a wait. This is normal. And now we go. And the rocket starts off very slow. And the reason it's very slow at the start.
Slow motion.
Well, true. Even if this was at normal speed, it would still look slow. And the reason it's slow at the beginning is because the mass is so big. Yeah. Anyways, off it goes. Barbecue. Yes. Right, okay, so in my small rocket, it has to wait about 1 second before takeoff. Okay, the next part. How long will the fuel last? Anyone know this part?
We know the weight of the fuel.
Well, how much fuel do you have? 90 kilograms. And how much fuel is used per second?
9.
9 kilograms per second.
So it's 90 divided by 9.
10 seconds. After 10 seconds, no more fuel. So then what will happen to the rocket?
Die. Fall.
Won't fall straight away. Okay? Is that part okay? The 10 seconds.
I get 10.1.
There is 90 kilograms of fuel.
Okay, so that makes sense.
Are you sure?
Yes.
Okay.
19 and 9.
Yes.
Mm-hmm.
Okay. Now the last part is what is the maximum height of the rocket, which is difficult. Okay, so let's have a look at it. So the rocket has a few parts. First part, it starts on the ground and it goes up, and then 10 seconds later, what happens? The fuel is gone. So here it has fuel, and then here it is stopped, no more fuel. What happens after this? Does it fall?
Not straight away.
Not straight away.
Because it has momentum.
Yeah, what will happen is it will continue until its speed is 0. So we're going to break this problem up into 2 parts. Part 1 is when the engine is on, and then part 2 is when there's no fuel left. Okay. Let's look at the first half. I'll call it A and B. So stage A. U is 0. V, we don't know. A, what's A? We don't know actually. T, we do know. What's the T? 10. And the S, we want. So what should I try to find? U, A, or S here? Well, it should be the A.
Yeah.
So if you look here, there are two forces on the rocket when it goes up. The first force is the weight, and the second force is the 900 newtons. So F equals ma, so A equals F over m, which would be 900 minus the weight over m, which equals
900 minus the weight.
Yeah.
The weight is
Wait a second. We need to think very carefully
you
before
don't
we
know what
continue. Yes.
the weight is yet, right?
No.
But in 10 seconds, but do you count when it's 10 seconds or
No, it's for the whole journey.
So but do you take half, right? What's the average?
Yes. Yeah. Okay. Can I continue here? Yeah. So what's the formula for weight? Well, that's mg. Now, here is the big question. What is the m? Well, the m is changing, isn't it? At the beginning, the mass is 91 kilograms at takeoff. And then at the end, what's the mass here? Anybody know here?
0?
No, 10.
Yeah.
Yeah, because in my little picture at the start,
Yeah.
it was 90 fuel, 10 cargo. So what we could use is we could say the m is roughly 10 plus 91 over 2. So then that would mean this equals sorry, I know it's not 91, it was something like 91 point, what was it? 91.74. Right, 10 plus 91.74 divided by 2. Okay, and then 900 minus that over that. Right, so here I got 7.88 meters per second squared. So that's this one here, 7.88 meters per second squared. So I can use this to get the V now. V equals U plus AT. So my V is 78.8 meters per second. Why 7 here? I use this formula, V equals U plus AT. The U is 0, the A is 7.88, and the T is 10. Is that okay? Yeah? Yes? Okay, and we need to get the S. What formula could I use for the S? I think probably S equals UT plus a half AT squared. Yeah? A half AT squared. So here I get 394 meters. Yeah? Okay, now stage B. Stage B. UVATS. The U is what? Anybody know?
The U is 0.
Nope. 78.8. The V,
Why is 78.8?
Yeah.
from here to here.
37.8.
That's the A.
Oh.
What's the V?
0.
0. What's the A?
7.8.
No. The engine is off.
Oh, so it's decreasing negative.
Yeah. So what's the A?
Negative 9.8.
Yeah.
1.
The T,
Don't know.
Don't know, and the s is what we want.
Mhm.
So I'll use v squared equals u squared plus 2as to get the s. Um, so I got 316.5. I can add that to the number here, and I can get the final height. About a 711 meters. How did I get this one? I add the two s's.
Add to what? Add, oh.
Yep. Huh? Did I turn it on? Or did I turn it off? What do you think? Correct. Would you like it on? Oh. Okay.
Thank you very much.
Oh, no problem. Okay. Any questions about the homework? No?
Can I see question E?
E. E. What was E? Oh yeah, the reason. Because the engine thrust is less than the weight. So Amanda, it's because thrust is less than the weight. Hey, oh yes, you have to go to the bank. I'll finish? Yes, okay. Alright. Sorry, Matt.
Yes.
Okay? Yes? Close?
Yes.
Close. Okay.